Here in this video, we are solving a small problem basing on thermal conductivity and coefficient of thermal conductivity. Let me have a look at the problem. A solid material of coefficient of thermal conductivity. So let us take down the data that is available for us. Coefficient of thermal conductivity K is given for you 50 in SI units. Is having a length of 1 meter. So L equal to 1 meter. Having a area of cross section of 5 centimeters square. I have to convert into SI system. 1 centimeter is 10 power minus 2 whole square. So that will be 5 into 10 power minus 4 meters square. One end of the rod is placed in steam. Means what? One temperature is steam has a temperature of standard 100 degrees centigrade. Other end is kept in ice. Theta 2 equal to 0 degrees centigrade. So if you try to draw the diagram, it will be like this, having some length, having some area. Here it is placed in steam. Here it is placed in ice. So being this is a higher temperature, this is a lower temperature, heat flows from left to right. How much of that ice melts in 5 minutes? So this ice melts because it is going to receive some heat. How much of that ice melts? So let us identify what are the concepts first of all that can be utilized here. Here there is some flow of the heat dq by dt. As we have explained so many times, rate of flow of the heat equal to coefficient of thermal conductivity directly proportional to area, difference between the temperature, and inversely proportional to the length of the conductor. Let me first find out how much heat is generated in this process. In 5 minutes, how much heat is transferred in this process. dq by dt is given to you as 5 minutes. I convert that into seconds for SI system, that is 5 into 60. Value of the K is given for you as 50. Value of the area is given for you as 5 into 10 power minus 4 in SI system. Delta theta is 100 minus 0. L is 1 meter. So dq by 300 equal to 5 into 5, 25. 1 0 and another 2 zeros, that is 10 power 3. And there is 10 power minus 4 by 1. That is 25 into 10 power minus 1. That is dq by 300. That implies dq equal to 25 into 300 into 10 power minus 1. 10 power minus 1 and 1 0 can be cancelled. That is 25 into 30. 25 into 3 is 75. So the energy that is available in 5 minutes is 750 joules. Once after knowing that energy available is 750 joules, we want to calculate this 750 joules can melt how much of ice. So for melting of ice, that means ice has to convert into water. There we shall remember back a definition called latent heat. Latent heat is defined as amount of heat required to convert the unit mass of substance from one state to another state at a constant temperature. So latent heat L equal to dq by m, where m is the mass because it's the heat required to convert unit mass from one state to other. From this I can write dq equal to ml. So where L is a latent heat, its latent heat unit will be automatically, heat is measured in joules per kilogram. I want you to identify that latent heat of ice is a constant value, that is 80 calorie per gram. We shall remember that. You know that, you have learned it in thermodynamics. But I want to convert that into SI system. 1 calorie means 4.2 joules. by 1 gram means 10 power minus 3 kilogram. So latent heat of ice will be 80, minus 3 becomes a plus 3 on the top. 4.2 into 1000 is 4200 joule per kilogram in SI system. Now I know dq value. I know the definition of latent heat as ml. dq is 750. How much ice melts I want to calculate. L is 80 into 4200. That implies amount of the ice that melts is 750 by 80 into 4200. One zero can be cancelled. That is 75 by 80 into 420. But be careful, you will get the answer in kilograms, which is a small value, so I can convert that into grams by multiplying with 1000 by 80 into 420. As I have multiplied with 1000, it becomes grams. Two zeros can be cancelled. So this value will be 750 by 8 into 42. So if you calculate, you will get it approximately as 2.23 gram. So in 5 minutes, 2.23 gram of ice is melt. So while solving this problem, we have used two basic and important things. One, definition of coefficient of thermal conductivity. Other, latent heat definition as amount of heat required to convert unit mass of substance from one state to another. Once if you know that, and also know a fact that latent heat of ice is 80 calorie per gram, solving the problem shall not be a difficult task. That's it. Thank you for watching.